This is Miss Plant's video. I'm going to be describing motion along a line, the displacement and velocity section in 5 minutes. It's for AQA Combined Science and Physics GCSE. So there are two kind of key definitions you need to understand: the difference between distance, displacement, speed and velocity. So distance is a scalar quantity, which means it just has magnitude. So your distance could be 50 meters, you've traveled 100 meters, etc. Whereas displacement is the vector quantity. So displacement doesn't actually tell you the distance you've traveled, kind of tells you how far you've got. Both of these values are kind of given the symbol S for this topic, so that's a bit weird, but you just have to get used to it. Displacement S, distance S. The scalar versus vector bit means that if you're traveling from A to B, the blue line here would show you the distance. If you were to measure that line, the length of that line, you'd get the distance you've traveled. Your displacement is this vector here from A to B, so it can be represented with an arrow. It has length and magnitude and direction. Speed versus velocity. Speed is given the symbol V. Velocity can be U or V. U is initial velocity, V is final velocity. Speed is a scalar, so it's just like 5 meters per second, how fast you're walking. Velocity is speed with a direction, so it's how fast you're walking, so it could be 5 meters per second east, 5 meters per second west. Speed with a direction, we sometimes just use plus 5 meters per second to say going right, minus 5 meters per second to say you're going left. Like if you're talking about equation, a problem on a page, it's probably just left and right you're dealing with. While we're on velocity, you need to know that because velocity is speed with a direction, if you're moving in a circle, if you're changing your direction, you are changing your velocity. So when you're moving in a circle, so for example, a planet, Earth orbiting the sun, or the moon orbiting the Earth, they are traveling at a constant speed, but the velocity is changing. You just need to be aware of that. And the changing velocity bit means that they're technically accelerating. So the Earth is technically accelerating as it travels in its orbit because it is changing its direction, so it is changing its velocity, even though the speed remains the same. For speed, you need to know that speed is rarely constant. So you set out walking 1.5 meters per second, it's unlikely that you're going to constantly walk at 1.5 meters per second, but you need to be aware of these values. You need to know that walking is 1.5 meters per second roughly, running is 3 meters per second, cycling is 6 meters per second. A car, 9 meters per second would be 20 miles an hour, so that's a small road. 31 meters per second would be 70 miles per hour on the motorway. You need to know all these values, and you also need to know the value of sound, and the speed of sound is 330 meters per second. Now, obviously, all these depend on different things. So if you're older, your walking pace might be slower. The terrain, if you're going up or downhill, if it's muddy, your fitness levels, and obviously the distance. So you might be able to run at 3 meters per second for 5 kilometers, but if you're going to do a marathon, it might be a slower pace. Right, we can calculate the distance by saying distance is constant speed times time. If the speed is constant, distance, the symbol for distance is S, measured in meters, V for speed, time for T, speed is meters per second, time is second. And this is for a constant speed. If we're not have a constant speed and you just do the distance and the time to find the speed, distance divided by time to find the speed, you just get an average speed. If the speed is not constant, this will give you an average speed value. You need to be able to interpret and draw distance time graphs. So distance time graphs, we put time along the x-axis, distance or S along the y-axis. So this graph here, it shows this initial section here is a steady speed, yeah? And when you've got a steady speed, you can calculate the gradient of that, and that will give you the speed. Yeah, so the gradient of a distance time graph tells you the speed. Flat section here means it's stationary. This bit here, the curve here, that means acceleration. And if you want to find the speed at any given point on it, so say I wanted to find the speed at that green cross, I would draw a tangent, and a tangent is a line that touches the curve at the important point, so at the green cross. I'd then find the gradient of that tangent, and then I'd use this thing that gradient is equal to the speed to find the speed. Again, this is up stationary here, and then this means I'm going backwards, and in this case it's very fast. Steeper the slope, the faster the object is moving. A very shallow slope means something is moving quite slowly. And that is it.